Buck O'Reilly, and welcome to another edition of MathCenter. Today we have a math league competition between the hometown denominators and those feisty irrationals. The topic? Solving systems of linear equations. Well, we have two correspondents out on the field to see the strategies that's being used. First, we have Lloyd Mayweather with those irrationals. Lloyd?
Thanks, Buck. I'm currently standing outside the Irrationals locker room, and I just spoke to head coach Grizzly McPherson, and he told me that he's going to eliminate the denominators with the elimination method. So I asked him to explain this elimination method to me. And this is how Grizzly explained it to me. First, you write down the two equations on a board or a piece of paper. So he gave me 2x plus y equals 4, 3x plus 2y equals 7. Then you draw a line down the middle to separate the two equations. So now you look at both these, and I see a 2y here, and I see a y. So now you're going to multiply this side by a negative 2 because you're going to get these y's to cancel out. So what happens is you get a negative 4x minus 2y is equal to negative 8. And now what you do, you bring this over here and you line them up. So negative 4x minus 2y equals a negative 8. And now you add them together. So here we get a negative x, 0 is equal to a negative 1. And then so we have negative x is equal to negative 1, cancel out the negatives, and we get x is equal to 1. So now we take this 1, bring it back over here, and we plug it into the original equation. Make sure it's the original equation and not this thing. So first, so we do 2 times 1 plus y is equal to 4. And we get 2 plus y is equal to 4. Subtract the 2, and we get y is equal to 2. But you're not done yet. Now you got to bring this over here, and you have to check it. And you plug it back into the original equation over here. So we have 3 times 1 plus 2 times 2 is equal to 7. So we get 3 plus 4 is equal to 7. 7 is equal to 7. And it checks. So you put a nice little check mark there. And now I'm going to say back to you, Buck.
Wow, Lloyd, the elimination method. That's as American as apple pie. That's going to be tough to compete with. Let's see what Annie Feathers is digging up over at the denominators locker room. Annie?
Thanks, Buck. I just got done talking with head coach of the denominators, Barry Garcia. Now, as we all know, Barry favors substitution method when solving systems of linear equations. This can be tricky, but Barry feels confident that is the best option for today's match, and it will bring the denominators the win they need. Barry explained the substitution method to me so I can show you. Using the same example Lloyd used, I'll show you the substitution method that Barry explained to me. Looking at this first equation, we see y is by itself, so we're going to solve for y. I'm going to subtract 2x from both sides, and I'll end up with y equals 4 minus 2x. Now I can plug in this equation wherever I see a y in the other equation. And here I get 3x plus 2 times 4 minus 2x equals 7. Now I can distribute. 3x plus 8 minus 4x equals 7. Now you see we can combine like terms. We get negative x plus 8 equals 7. Now we're going to subtract 8 from both sides, and we get negative x equals negative 1. We can cancel the negatives, and we end up with x equals 1. Now I can bring this back over to the first equation. 2x plus y equals 4. I can plug in y, 1 for x. 2 times 1 plus y equals 4. We get 2 plus y equals 4. Now subtract 2 from each side, and we get y equals 2. The same answer Lloyd got the first time.
Thanks, Annie. That was lovely. Well, folks, there you have it. 2 methods to solve one problem. Gotta love math. This just in. We just received an actual problem from the Math League competition. Let's see if you can figure this one out before the mathletes do. 9x plus y equals 56, and 6x minus 5y equals 128. Use any method. The choice is yours. Well, until we meet again, remember, numbers are tools, not rules. This is Buck O'Reilly. EMN. Today's Math Center brought to you by Algebra Depot. Everything algebra, all the time.